We start with the direct part of the proof. So it's not possible just to use random coding. But what was the idea of Wolf and Slepian? The idea was that they don't generate one code word for each index, but they generate several code words for each index. So in this case, they generate 2n_r1 prime for each code word. That's for encoder 1. And encoder 2, of course, generate 2 to the n r2 prime code words for each index w2. So we have in totally 2 to the n r1 plus r1 prime code words xn of w1 and v1, where w1 goes from 1 to 2 to the n r1, and v1 goes from 1 to 2 to the n r1 prime. So they have to, the encoder 1, for example, has to choose n times 2 to the n r1 plus r1 prime symbols, independently using the distribution px. Same is done by encoder 2. So that we have at the end such a scheme here. So encoder 1 is here, and here we have encoder 2. What is now the idea of the code encoding? So encoder 1 tries to find w1 tilde and v1 tilde such that the received sequence xn of the source, which was emitted by the source, is equal to xn of w1 v1. So he chooses, look at his code book here, at the big code book, and look if there is such a pair. If there is more than one of these pairs, then he use a predefined function. Perhaps this function just chooses the first one. And if unsuccessful, then the encoder 1 just chooses w1 v1 equal 1 1. The same is done by encoder 2 to treat yn, which is also emitted by the source, and how to transmit w2. So encoder 1 chooses w1 v1 and or w1 tilde v1 tilde and submit w1 tilde, and the same is done by encoder 2, who transmits then w2. Now the decoder, he received w1 and w2. Now he have, of course, shared the coding table with encoder 1 and encoder 2. Thus, you try to find a pair v1 tilde and v2 tilde such that xn of w1 v1 and yn of w1 v2 is typical, jointly typical. And if successful, he put out the corresponding sequence. If unsuccessful, he just put out xn w1, 1 and yn w2, 1. How can we analyze this? Again, we wish to bound the error probability such that the estimate of xn and the estimate of yn is not equal to xn and yn. This is the average error probability over all code books. Again, we use the idea of the theorem on total expectation. So we look at several events which sum up, which probability sum up to 1, and look then at the probability that an error happens under the condition that event 1 happens, like we did it before. What kind of error events do we choose? So the first error event is very simple. We assume there is no xn and yn such that it's jointly typical. That means the source sequence is not jointly typical. Then we can do nothing somehow. The second error is that encoder 1 cannot find an estimate xn w1 V1, that is xn. That means we have all events that there is no W1, V1, such that the xn of W1, V1 is equal to xn. The same error probability we have for encoder 2, that's the event 3. That means the encoder 2 cannot find an yn such that it is equal to yn. So in both cases, in the codebooks, they don't find the sequence which is emitted by the source. That's the error event 2 and error event 3. The error event 4 is that the decoder choose the wrong pair, W1 tilde and W2 tilde. For this case, we look at the events that V1 and V2 is equal small v1 and v2, but v1 tilde and v2 tilde is unequal to v1 and v2, and the sequences are typical. So we take the union over all these possibilities. And then, of course, the event E4, that the decoder could choose the wrong pair, is equal to the union over all V1 and V2 of this events E4 of V1 and V2. Now we use the union bound again, and we say that the error probability is smaller than the probability of E1 plus the probability of E2 and E1 complement plus the probability of E3 and E1 complement plus the probability of E4, E1 complement, E2 complement, and E3 complement. To see this, we will look at the following.